Okay, I'm going to get started this morning. We're going to be on page 311. I'm going to go through the remaining working examples for reciprocal function, and then you'll have time today to work on the reciprocal. So the first thing they do is they give us f of x is equal to 2x plus 1. And then they ask us to sketch the reciprocal of it. So the reciprocal of that would maybe be g of x is equal to 1 over 2x plus 1. Okay, so we have to graph. So I'm going to use the pen and paper method on page 312 so that you get a better idea of what to do and what the steps are. So the first thing I do is I graph y equals 2x plus 1. Okay, so the y-intercept in this case is 0 and 1. That's right here. All right. My slope tells me to go up 2 and over 1. Right there. Okay, minus 1 and 1. All right, so there's my graph of y equals 2x plus 1. Now I need the reciprocal of that graph. So the first thing that I do with the reciprocal of that graph is I find out where y is equal to 0, and I draw an asymptote in there because 1 over 0 is an undefined value. So that occurs right here. So the first thing I do is that. So if you're filling in your box, it says the x-intercept for y equals 2x plus 1. That value will be negative 1/2 and 0. So right there, that's negative 1/2 and 0. All right. There's no asymptotes for the y equals 2x plus 1 graph. Now the invariant points. The invariant points are where y is equal to 1 and y is equal to negative 1. So those are your two invariant points right there. All right, at plus 1 and negative 1. So the invariant points are at 0 and 1 and at negative 1. I think it's negative 1 and negative 1. I'm just going to do this in my head here. 2x plus 1, subtract 2x. Yeah. Okay, so the invariant points right here and right here. So those are 0 and 1 and negative 1 and 1. Negative 1 and negative 1, sorry. And now at this point, I draw my sketch. Okay, so what we learned last week is that all the y values between here and here, between 0 and 1, they're all fractions. So when I take 1 over them, they become whole numbers and they become much larger. So my graph goes like that. And then all of the values up in here, when I take 1 over all these values, they all become fractions. And they all approach this line right here, which is one of my asymptotes. So my asymptote is at y equals 0 and x equals negative 1/2. Those are my two asymptotes. And then the final, I just draw it like this. The same on both sides. So the green is my new graph. The red was 2x plus 1, and the green graph is 1 over 2x plus 1. So the first thing that I do is I draw my original graph, which was 2x plus 1. And then the second thing that I do is I mark off my asymptote. So that's where y equals 0. That's where my original graph crosses the y-axis or the x-axis. My third thing that I do is I put my invariant points in. And then the fourth thing I do is I draw my sketch, and I sketch it. And again, I said this is an important graph for us because when we get into grade 12, there are 5 graphs that we need to know the base graphs of. This is one of them, and that is the 1 over x graph. All right. So it's not super difficult with the graphing of a line. and taking the reciprocal of the line. But we're going to look at the next one, which is the graph of the reciprocal function for a quadratic. So let's have a look at example 3. Example 3 on page 313. So I've got f of x equals x squared subtract 1. Okay, so I want to graph the reciprocal of that. So the first thing I do is graph the original. All right, so my vertex for this graph is 0 and -1. Right there. Okay. My intercept values, my x-intercept values are going to be 1 and -1. So that's right here and right here. So now I draw my parabola out this way and out that way. All right, so there's the graph of y equals x squared subtract 1. You have technology that can aid you in graphing this, all right? But you've done enough work with parabolas, you should know how to find that vertex. You should know how to find your x-intercepts, which is your root, so your zeros are your function, okay? Now at this point, so I graph the original. Now I mark off my asymptotes. In this case, there's 2 vertical asymptotes. So again, wherever it crosses the x-axis, I've created asymptotes. All right. Then I mark off where my invariant points. So where y equals 1 is here and over here. Where y equals -1 is right here. Okay, so those are my 3 invariant points in this question. And from this, I need to draw my sketch. So it goes up towards this asymptote, down towards that asymptote. Same thing over here. Like that. And then on the bottom here, I keep that point because it's an invariant point, and my graph opens like this. So it looks like it has a mini parabola below the line. All right. So I graph the original. I mark off my vertical asymptotes, my invariant points, and my shape or my sketch.
How do you find your vertical asymptotes?
Okay, so what an asymptote is, it's a spot on the graph where I can't get an actual value for. So where is it in a graph that I don't get an actual value? Well, let's do this. I'll show you algebraically first. So I have that. I want to graph f of x equals 1 over x squared subtract 1. Well, I know from all the work that we've done that I can't have a 0 in the denominator. So that means that x squared minus 1 can't equal 0. X squared cannot equal 1. X cannot equal plus minus 1. So there's where my asymptotes occur at plus minus 1. Well, if I've drawn the original, this green line was my original, okay? Wherever it crosses the x-axis is when y equals 0. Well, this is what I'm doing. I'm actually taking 1 over f of x or 1 over y. So my asymptotes always occur, the vertical asymptotes always occur where the original graph crosses the x-axis, because that's a 1 over 0 value and that's undefined. You could draw it out, and actually, if you, we can do this on the calculator, and I'm going to show you how to get to the table. So I'm going to clear my graphs off my calculator, and I will graph, I'll do it on, what's easier? I'll do it on the board here. Okay, now it's very, very difficult to see. Sorry about that, I can't make it any right, but what I want you to do and what I want you to take from this is actually this though. I need to find there. Okay, so what I wanted to show you here is if you used your calculator to do this, you would see at -1 you would get an error, and at +1 you would get an error. So when I take 1 over my y values, those 2 points there are going to give me y equals 1 over 0, which is an undefined value. And that's where my asymptotes occur, my vertical ones. So at -1 and 1, which is where it crosses this axis right here. All right, it would cross the axis right there and there. So I showed that right here. This point here is -1 and 0. This point here is 1 and 0. All right? Does that help?
Yeah.
Okay. All right. So that's all there is.
I have a question.
Yeah, go ahead.
How did you find the invariant points? Like I saw, like they're all kind of one out from your asymptotes there. Is there a reason why you did that, or is there like
The
a way
invariant
to do it? So yeah.
The invariant points is where y is equal to 1 and -1. All right? So on your original graph, I mark off, so my green line was my original graph. Here, let me do this again from scratch so that you can see it again. All right, now remember, this is the graph of y equals f of x. All right, I want to graph y equals 1 over f of x. So when I take 1 over 1, I get 1. When I take 1 over -1, I get -1. Those are my invariant points. So at where y is equal to 1 on the graph and where y is equal to -1 on my original graph, I mark those coordinates off because when I take 1 over that value and 1 over that value and 1 over that value, I end up with the same value. All right? So first thing I do is my asymptotes. And then I mark off where y is equal to 1 and y is equal to -1. Those are the invariant points. And then I shape it after. All right? Do you understand what I'm saying there?
Yeah, that makes a lot more sense now.
Okay, perfect. Okay? So that takes care of all of the graphs there. What I want you to do, I guess we should look at example 4. So go to page 316. It gives us the graph of a reciprocal function, y equals 1 over ax plus b. So that's a line where a can equal 0, b can equal 0 is shown. Sketch the graph of y equals f of x. All right, so we're actually working backwards on it, on this question. So they give us a graph. And on their graph 3, okay, so there's the graph that we have, and it wants us to graph y equals f of x. Well, if you work it backwards, so I've already got the sketch. If I work it backwards, I have my invariant points, okay? And I know that that line has to cross this axis. So essentially all I'm doing is taking a line and drawing it through the two invariant points in the y-intercept, or the x-intercept, sorry. And there's my graph of my new line. Okay, and then it wants you to find the equation of that line. Okay, so I need y equals mx plus b. Well, to go from here to here, I go up one, right one. That gives me that slope. And then I need to find out what my y-intercept is there. All right, and I can't really tell from this graph. So I would probably have to plug a point in. So I would plug in 2 and -1. B is equal to -3. The equation of that graph is y equals x minus 3. So I'm basically using my grade 12 or grade 10 skills in order to come up with the equation y equals mx plus b. So we follow through. If we follow through in our book here, it says y equals 1 over f of x, y equals 1 over f of x. It is a, what does it say? A linear or quadratic function? Well, that's a linear function. All right. And it says the graph of y equals 1 over f of x has a vertical asymptote at x equaling, so in that case it was negative or positive 3. So f of x has an intercept at 3 and 0. The graph of 1 over f of x has the invariant points at 2 and 1, or sorry, 4 and 1 and 2 and -1. Plot the x-intercept and the variant points, draw a line through the points. So that's basically what I did on that. So if you follow through the solution on page 316, that's kind of how I followed through with it. All right. Okay, so what I want today, I still don't have all of those assignments in, so we got to make sure that we're attempting to get those assignments in today. I'm still getting emails of the assignments. I would prefer if you could try and get it back into Teams. That would be ideal. But I know there's still some complications with it, but I got better here. I got 6 out of, okay, that's better. I see some more got turned in on that Teams today, so that's great. Okay, so what I want you to do right now is you have the remainder of, I'll leave you on for another 20 minutes or so. You can go through page 318 and 319. Maybe even up to 320. If you get to 320 by the end of today, you've done good work. Okay, so I'm going to mute my microphone, and you guys can hang on there, and you can continue to work through this morning. All right. Okay.